All right, this is the video solution guide to the reading solubility curves worksheet. All right, so starting out, it says what salt is least soluble in water at 20 degrees Celsius. So what we need to do is we need to look here, and here is 20 degrees Celsius. And so we're looking for the one that has the least amount that can be dissolved. And so we're looking for the lowest line. That belongs to potassium chlorate. KClO3 is the least soluble at 20. Next question says, how many grams of potassium chloride can be dissolved in 200 grams of water at 80 degrees Celsius? Well, we need to find potassium chloride. Potassium chloride looks like it is right here. Okay, and notice it's wanting to know in 200 grams of water. Well, this sheet does it in every 100 gram of water, so we're going to have to make a proportion on this one. Notice that it is at 80 Celsius, so I look and see where 80 Celsius intersects. Okay, and it looks like I can hold 50, all right, in 100 grams. So basically what we're going to do, and you can probably do this in your head, I'm guessing, but essentially what we're going to do, we say, all right, there are 50 grams of potassium chloride that will dissolve in 100 grams of water at that temperature. Well, we don't have 100 grams of water, we have 200 grams of water, and we want to know how much salt is produced, or how much salt could be dissolved. So with this equality, we got the proportion to solve for x, you cross multiply and divide. Okay, so basically the 200 comes up here. So you take 200 times 50 divided by 100, and you're going to get 100 grams of potassium chloride. This one says at 40 Celsius, how much potassium nitrate can dissolve in 300 grams of water. So once again, this is just kind of like the last one. So we have to find potassium nitrate. That's this guy. Okay. And 40 Celsius, right? Okay, but once again, it's 300 grams of water, so we need to do a little adjusting here. Let's see. And at 40, and there's going to be a little wiggle room here because it doesn't fall exactly on the line. Let's say I think maybe there are 62 grams of potassium nitrate that dissolve in every 100 grams of water at 40 Celsius. Notice we don't put the temperature in the proportion. We never use the temperature in the calculation. It's only used to read the graph. And then we want to know 300 grams of water. Okay, well, solve for x. Once again, you're cross multiplying and dividing. 300 comes over here. So I'm going to take 300 times 62 and divide it by 100, or essentially you're taking 62 times 3 is what it ends up being. And that's going to be 186 grams of KNO3. Number 4, which salt shows the least change in solubility? So you're looking at over that temperature range 0 to 100. We're looking for the one that has the least amount of slope. Okay, the least change in rise over run. If you look at all of them, you'll find that sodium chloride has the least variation in solubility. Okay, number 5, at 30 degrees Celsius, 90 grams of sodium nitrate is dissolved in 100 grams of water. Is it saturated, unsaturated, or supersaturated? Well, we've got to find sodium nitrate, which is this guy, NaNO3. Okay, and it says we're looking for, what does it say, 30 degrees Celsius. So here's 30 Celsius. Okay, and we're trying to see a point. It says that it has dissolved 90 grams of sodium, which would be a point right here. Notice we are under the line. That is unsaturated. Anything that is under the line is unsaturated. Anything that is found directly on the line is at the saturation point. It's saturated. Anything above it is super saturated. Okay, number 6, it says a saturated solution of potassium chlorate is formed from 100 grams of water. If the saturated solution is cooled from 80 degrees Celsius to 50 Celsius, how many grams of precipitate could be formed? Well, let's take a look here. Let's highlight this guy and see. So we have potassium chlorate, which is going to be this guy, KClO3. Okay, and we have two temperatures this time. So we saturated at 80, and then we're going to cool it to 50. All right. So essentially what we're looking at here is we know so in 100 grams of water at 80 Celsius, it looks like it'll dissolve 40 grams of KClO3, we'll say at 80 Celsius. But then if we cool it down to where it's at 50, we're still up here at 40, but it looks like it can only hold 20. Okay, so it should only be able to hold 20 grams of KClO3 at 50 degrees Celsius. So if this were to be agitated or a seed crystal or something were to be added, you would notice that you would have 20 grams of KClO3 could precipitate out. That's all you do. Okay, next one. What compound shows a decrease in solubility from 0 to 100 Celsius? There's actually two of them. So either answer would have been acceptable. This guy, ammonia, or this one, cerium sulfate. So either one of those would be acceptable for the answer. Which salt is most soluble at 10? So which one would dissolve the most? Well, you have to look here is 10 degrees Celsius. The one that you can dissolve the most of is potassium iodide, Ki. Okay, which salt is least soluble at 50 degrees Celsius? So we got to look at 50 degrees Celsius, and we're looking for the lowest line. That would be the cerium sulfate. Which salt is least soluble at 90? Here's 90. Cerium sulfate again, the lowest one. Okay, this should be a number 11. How many grams of ammonium chloride can be dissolved in 225 grams of water at 90 Celsius? So we've got to find ammonium chloride. That's this guy. And then it says the temp is what, 90? So here is 90. And so what we can determine from the graph, we know that it'll dissolve, it looks like what, 70 going across here? Okay, so we can dissolve 70 grams of ammonium chloride in 100 grams of water. But we don't have 100 grams of water, we have 225 grams of water. You know, and as you guys are setting these up, as long as the water is on the same side, meaning the numerator, the denominator, same thing with the salt, you can flip that fraction either way. It doesn't matter. You know, you could invert these, you'll get the exact same answer. I like having x as a numerator. Okay, the grams of water cancel. 225 times 70 divided by 100. When you do that, you should get 158 grams of ammonium chloride. I guess I didn't finish the chloride part, so there you go. 158 grams of ammonium chloride. Number 12 says at 20 Celsius how much sodium chloride can be dissolved in 640 grams of water. So we need to look at sodium chloride, which is this, doesn't change very much. And we said 20 Celsius, so it looks like to me that's maybe, maybe 38. So we'll say 38 grams of salt, sodium chloride, in 100 grams of water. Well, we didn't have 100 grams of water. We have 640 grams of water. Solve for x, cross multiply, the 640 comes over here. All right, 640 times 38 divided by 100. When you do that, 243 grams of salt will dissolve in that quantity. This should be 13. What substance is not a salt? Well, this one, ammonia. You know how you know it's not a salt? It's molecular. It's made of all nonmetals. Okay, basically, when I say a salt, they are these ionic crystalline solids. So you have a metal and a nonmetal, right? A cation and anion. Ammonia is not. It is covalently bonded. That is a nitrogen sharing electrons with hydrogen, all nonmetals. So what you're going to find out is that the solubility of molecular substances, things that are all nonmetallic, they tend to decrease with increased temperature, whereas most ionic substances do increase. So if you have a metal and a nonmetal, they tend to dissolve more when it gets warm. Now you might say, what about this cerium sulfate? Because it's ionic. And that's why I said most. There are some exceptions. That is one of them. But the one that isn't a salt would be ammonia. Okay, we're to number 14, I believe. It says at 40 Celsius, there are 130 grams of sodium nitrate dissolved in 100 grams of water. I want to know if it's saturated, unsaturated, or supersaturated. Well, let's see. So we have sodium nitrate, which is NaNO3. That's this guy. And it says there are 130 grams dissolved at 40 Celsius. We need to find here is 40. And so it says we have a point that is 130. So 130 would be right here. Well, we're above the line. Supersaturated. Okay, it's dissolving more than it should have. Now, if I ask the question, what's the minimum temperature that had to be to dissolve that much to form that supersaturated solution, all you would have to do is go and see where this line intersects. Okay, and so it looks like, the temperature was at least, I don't know. Oh, it's probably right about here. Probably, 65 or so, 66 Celsius. I could ask a question like that, but you guys could answer that. So you're just looking, seeing where that intersected, and so somewhere in there. Okay. What is this, 15? Okay, at 80 Celsius, 15 grams of potassium chloride are dissolved in 100 grams of water. How much more potassium chlorate in grams could be added to form a saturated solution at 80 Celsius? So we need to find potassium chlorate, which is this guy, KClO3. And we said 80 Celsius, right? And so we said we have 15 grams in there. So 15 would be right about here, right? But it says it wants to saturate it. Well, it looks like it can hold 40. So if you can hold 40 grams at 80 degrees Celsius, but you've only got 15 grams at 80 degrees Celsius, how much more can you dissolve? Should be 25 grams more. And we can put the KClO3 there. Okay, so you can dissolve 25 more grams. Okay. Last one. Which salt is the most soluble at 50? Okay. And so you look at this, and you're like, okay, here's 50. Some of you may have said, oh, it's sodium nitrate. It's not. You might say, what? Well, what you have to recognize, what about this guy? Where did the Ki go? I'm like, well, it's not on the graph. Exactly. So it's on here. It's continuing on up here somewhere, right? And it's not like it went up and like came down sharply. It didn't. So we know that it's got to be potassium iodide because it's somewhere off the graph. Its solubility is in the stratosphere. Okay, so if you guys have any questions, let me know. But I think it's pretty straightforward. Reading graphs. Thank you.